Hey guys, today we are talking about what happens when we have rational exponents. Now, rational is just a fancy word for a fraction, and so it's pretty much asking what happens whenever we have a fraction as an exponent. Well, the answer to that is whenever you have a fraction as an exponent, it creates a root. So, for instance, here is my base. So this is going to be my base. Let's see if I can get that going. That's going to be my base. And then if we have a fraction as an exponent, the top of the fraction is the exponent part. That's the power. And whatever the bottom is the index to my root. So remember, take this to the same base. Whatever the bottom is the number that's outside of my root. Whatever the top is the exponents that it can be raised to. Now, it can be written one of two ways. We can either write the exponent on the inside or the outside, or, but our index is always going to stay right there on the outside of my root. Okay? So let me give you some examples. So really, all we're doing today, guys, is rewriting. And so once you learn the pattern, it's really simple. So let's take a look here at number 1. So number 1, we have the fourth root of 81. Well, we can write this as 81 to the power of 1 over 4. Okay? Because 4 is the index of the root that we're doing. So we create that fraction. 1 over 4 creates that root. Now, we could put parentheses around the 81, or we could just leave it like this. However, whenever we have a negative, like this next one here, it's important that I put the negative inside parentheses because it is also a part of that root. Okay? So this one's negative 125 raised to the power of 1/3. Okay, we can also rewrite it the other direction. We can start with a fraction as my exponent, and we can rewrite it as a root or whatever. Okay, so let's take a look here at number 3. So number 3, we have negative 216. Okay, so we're going to raise that to the power of 1/3. So that actually means the third root of negative 216. Number 4 here, we're going to have 64 raised to the power of 3 and have an index of 2. So remember, the number on top is my power, so I can write it one of two ways. I can go 64 to the power of 3 with a square root, or we could just write it as square root, or we could write it like this. The square root of 64 raised to the power of 3. The only thing is, the important thing is that the number on top is my power, wherever we place it, and the number on bottom is my index. And we can write it with a square root, with a 2 there, but a square root just by itself has an invisible 2 right there. Okay? All right, number 5, we have 243 raised to the power of 1/5. So I'm going to go the 5th root of 243. Technically, there's like a little 1 right here, right? But we don't have to write that. It's just assumed. Okay, so if you ever have a fraction that's a 1 over something, you don't actually have to write the second part. All right, let's keep going. We're going to keep practicing this. So you either have it as a radical, which is with the roots, or you have it with a rational exponent or a fraction exponent. So if it starts off with a root, we're going to write it with a fraction exponent. So here's my number 7. It doesn't have a negative, so I do not need to write the parentheses. But we have a 3 as my exponent and a 4 as my index, so I can write this as 7 to the power of 3/4. For this one does have a negative, so make sure you write your parentheses whenever you do this. So we're going to go negative 30 to the power of 2 over my index of 3. So this one's negative 30 to the power of 2/3, and make sure you put your parentheses if you have a negative. Number 8, we have 16 to the 3 over 2. Remember, there's two ways that we can write this. We can write this as 16 to the power of 3 with the square root, or we can write it as the square root of 16 to the power of 3. So either way of these is correct. I usually just prefer to put the power on the inside. It's a lot easier. Okay, number 9 here. You have 32 to the negative 3 over 5. Okay, so we learned last week that if we have a negative exponent, we flip our number, right? Well, you don't have to really worry about that right now. We're just rewriting. You don't have to simplify or anything, okay? So we're just going to go 32 to the negative 3 with the fifth root around it. Or we could write the fifth root of 32 raised to the power of negative 3. Okay? Either one of these is correct. All right, sometimes we have a more complicated thing inside my root, but we still just write it the same. Here I have 2x plus 7. We're going to make sure that we put that 2x plus 7 in my parentheses. So anything inside the root gets a parentheses. Anything on the outside of the root does not go inside the parentheses. And this is raised to the power of, well, there's no power that raises, it's just 1 over 3 because my index is 3. My next one, 8 to the power of, 8 times the square root of x. We could also write this as 8 times x to the power of 1/2. Remember, there's an invisible 2 right there. Like on number 12, this one is very particular. You're going to see one like this, and it can sneak up on you and trick you. This 2 does not go on the inside. This 2 is on the outside. And we're going to build a parentheses for that root. Okay? So we're going to leave that x minus 3 inside the parentheses. Then this has an index of 4, so it's going to be raised to the power of 1/4. So this is my answer for number 12. Okay, here we are going to start off with the fractional exponent, and we're going to rewrite it as a radical, as a root. So it's going to be x raised to the power of 2 divided by 3. So we're going to have x to the power of 2 and the third root, or we could write this as the cubed root of x squared. Should give myself a bit more space there, shouldn't I? All right, so it could be x squared to the power of 3, or the cubed root of x squared. Okay, either way. Same thing goes here. We're going to have 3x on the inside of my cubed root squared, or make sure you leave the parentheses inside here, or you can write it as the cubed root of parentheses 3x squared, because that squared applies to both the 3 and the x. So parentheses matter a lot in today's lesson. On this next one, notice this 2 is not being affected by that 1/3, right? This 2 is not being affected by that 1/3. There's no parentheses. So it's just going to be 2 times the cubed root of x. This one, we're going to have the square root. You can put the 2 or you cannot, of 2x minus 1, and it's all going to be on the inside. Okay, so that's how we rewrite these. Now, let's take some time to evaluate these with or without a calculator. So here, to remember, to evaluate these without a calculator, we are going to cake it. Now, the number that we have to circle to bring a number to the outside is going to be whatever my index is. So for instance, number 17 here, we're going to start with 81, and I'm going to cake it. So I'm going to go 81 divided by 3 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. And then check it out. We have a group of 4 3s, and that is my index. So we have to find a group of 4 to bring it out, and then that's just my answer. I don't have anything left over. My answer is just 4. Okay, now let's take a look at negative 250. The first thing I want you to realize about negative 250 is this is a cubed root. So it's not an even number. It's a root to the power, it's a root of 3. So that means this negative is going to stay negative. So whatever my final answer is, it's going to be negative. Then we can take that 250 and I can cake it. So I'm going to go 250, let me fix that 5. We're going to go 250 divided by, let's start with 2. That gives me 125. Then let's go with 5. 125 divided by 5 is 25. And then 25 divided by 5 is 5. And then check it out. We have a group of 5s here, and my index is 3. So we're looking for groups of 3. So we're going to bring a 5 to the outside, and we're going to have left over a cubed root of 2 on the inside. Okay? All right. The same basic idea happens with a rational exponent. Okay? So here, we're going to rewrite it as a radical first. That can help us find our answer. All right? So I'm going to rewrite this first as the cubed root of negative 216. Then we know what to do with it. Then I know I need to take that negative 216 and I need to cake it, right? My final answer is going to be negative because it's the cube root of a negative, and we're going to cake 216. So we're going to go 216 divided by 2 is 108. 108 divided by 2 is 54. 54 divided by 2 is 27. 27 divided by 3 is 9. And 9 divided by 3 is 3. So check it out. We have a group of 3 2s. And remember, that's our index. That's what the number we're looking for. We have a group of 3 3s. So we're going to pull a 2 to the outside, and we're going to pull a 3 to the outside, right? So we're going to have negative 2 times 3 is going to give me a final answer of negative 6. There's nothing left inside here, so that's it. So that's just going to be my answer. All right, so let's rewrite this one so we can see where we go from here. So we're going to write this as the square root of 16 raised to the power of 3. So take it step by step. First, let's find the root, and then let's raise it to the power. So, because you see, this is my root, this is my power, this is my root. So take your root first, then raise it to the power. So we're going to cake 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. And so we're going to have 2 groups of 2 that we can pull to the outside. So we're going to have 2 times 2 is 4. And we already knew that. The square root of 16 is 4. So now I'm just going to go 4 cubed, and 4 cubed is 64. So that's going to be my answer. Okay? All right, now let's take a look at 21. So 21, we have 192 raised to the power of 1/5. So let's rewrite that as the 5th root of 192. And then we can cake that 192. I can go 192 divided by 2 is going to be 90. Is going to be 96. 96 divided by 2 is going to be 48. 48 divided by 2 is going to be 24. 24 divided by 2 is 12. 12 divided by 2 is 6. 6 divided by 2 is 3. Okay, now we're looking for a group of 5, right? So I'm going to grab 5 2s as one big group. So we're going to bring a 5 to the outside times the 5th root of what's left over, a 2 and a 3. So we're going to have 2 times 3 on inside. So, not 5. Of course not. This should not be a 5 here. I'm so sorry, guys. This should be a 2, right? We have a group of 5, but the number itself is 2. So then we're going to go 2 times 3 on the inside, so it's going to be 2 times the 5th root of 6. And that's going to be my final answer. Okay? All right, let's turn the page. And let's talk about how to use our calculator to be able to solve these problems. Okay? So, to be able to solve these problems, I'm going to pull up my calculator, but let's take a look here. These are the instructions. So to get an index like this, we can raise to the power of whatever number we are working with. Okay? So, for instance, we can have the square root of 64. We can plug this into my calculator. This one's easy. Second square root of 64 equals 8. So square root of 64, 8. What about the cubed root of 64? Okay, let's pull this back up. To get the cube root, I have to go math 4. To get the cube root, I'm going to go 64, hit enter. That equals 4. Easy stuff. But what about the fourth root of 256? To get the fourth root of 256, we have to go math, and then number 5 right here, okay, gives us our root. And we're going to put a 4 up in the top. We're going to go over 1 and plug in 256. And that gives me my answer. The fourth root of 256 is 4. What about the fifth root of 32? Once again, we're going to go math 5. We're going to go fifth root of 30. What was it? It was 32. Fifth root of 32. Hit enter. Hey, that's 2. Okay? So to be able to find these, we just break it down piece by piece. Okay? So for instance, let's look at number 22, and let's plug this into my calculator. Okay? So we're going to go negative 4th root of 7 cubed. So we got a lot going on here. So we're going to start with the negative. Okay? Well, we're going to start with the parentheses. We're going to go negative, and then we got to go fourth root. So we're going to go math 5. That negative is not going to be there. That negative is going to be out in front. Sorry about that. Negative fourth root of 7. Close off our parentheses, and then we're going to raise this to the power of 3. So remember where your power button is. It's over here. So raise to the power of 3. So it takes a while to plug it in, but it gives you an immediate answer. So our answer is negative 4.303. We're going to raise to the third decimal place, so we're going to raise this to negative 4.304. Okay? So negative 4.304 is our answer for this one. What about number 23 here? Well, we can plug this into our calculator too. I can go the third root of negative 30 squared. So pull up our calculator, and we can go brackets, math 4, third root of negative 30, close those off, oops, close it off, and then raise it to the power of 2, hit enter, and we're going to get 9.654, or round it up, 9.655. And there is our solution. Okay? Same thing goes for 24. We have negative 16 to the power of 3 over 2. Negative 16 to the power of 3 over 2. This one's even easier in our calculator. We just go parentheses, negative 16. Don't forget your parentheses on a negative. Raised to the power of 3 over 2. And it gives us, oops, an error for no answers because of that negative. So let's put it in the exact way it's written out without the parentheses. Let's go negative 16 to the power of 3 over 2, and that's going to give us our answer of negative 64. Okay, and our last one, 32 to the power of negative 3/5. 32 to the power of negative 3/5, and that's going to be 0.125. 0.125 is going to be our answer there. All right, guys, we're going to do the last 4 problems here for this lesson. So we're going to start here with number 26, and this is just like problems we've done in the past, but we're used to seeing like 4x squared, 4x cubed equals. But today we have 4x to the 5th. Well, it's really the same basic idea. We're going to isolate the term that is being raised to the power. So to do that here, we would have to start off by dividing both sides by 4. And so we're going to get x to the 5th equals 128 divided by 4 is going to be 32. Okay? And then we're going to take the 5th root of both sides. To clear out this x to the power of 5, we're going to take the 5th root. All right, so to do that, we're just going to need to pull up our calculator, right? And we're going to go math 5, and that gives us our root, and we're going to go the fifth root of 32. And the fifth root of 32 equals 2. So my answer is going to be, this cancels, we're going to get x equals the fifth root of 32 is 2. Now something that's important to remember, if your exponent is odd, use only positive or negative. So this one's only positive 2. However, if my exponent in my problem is even, that's when we use plus or minus. So like if it's squared or to the fourth power, we're going to have to use plus or minus and split it into two equations. For example, this one. This one has a 4 as my exponent. And so that 4 is going to mean that we're going to get two answers. If we have an even exponent, we're going to finish with two answers. So let's go ahead, let's clear this out. We're going to take the fourth root, not the third root, the fourth root of both sides. This fourth root and this to the power of 4 cancel, so I'm just going to have x minus 3, and then we're going to take the fourth root of 81. So once again, we're going to pull up the calculator, and I'm going to go math 5, plug a 4 in the top, fourth root of 81, hit enter, and it's going to be 3. So we're going to have x minus 3 equals 3. But remember, since this is an even exponent, we're going to say plus or minus 3. So we're going to split this into two problems. We're going to have x minus 3 equals positive 3, and x minus 3 equals negative 3. All right, so if it equals positive 3, add 3 to both sides to get this answer. And we're going to get x equals 6. But that's only one of my two answers. My other answer is going to be here. We're going to add 3 to both sides here, and we're going to get x equals negative 3 plus 3 is 0. So there's our two answers, x equals 6 or x equals 0. All right, let's keep moving on. We'll do our last two here. Number 28. We're going to need to get this parentheses by itself, all right? So we're going to need to get this parentheses by itself. So to do that, we're going to start off by adding 13 to both sides. It's going to give me 3. It's going to give me 3 times x minus 4 cubed equals 24. Then I need to divide both sides by 3. We're going to get x minus 4 cubed equals 24 divided by 3 is 8. Then we're going to take the cubed root of this side and the cubed root of this side, and I'm going to get x minus 4, because these will cancel, equals the cubed root of 8 is 2. All right, now since it's a cube, we're not going to do plus or minus since it's odd. So now we just have one answer. To get to that answer, all I have to do is add 4 to both sides, and we get x equals 6. All right, guys, let me make that a little bit better. X equals 6. All right, last one. This one has a 4 there, which means we're going to get two answers because we have an even exponent. So I can write this out here. We're going to start off by adding 43 to both sides. And we'll get 3 times 7x minus 4 to the 4th equals 243. Divide both sides by 3. And that's going to give me 7x minus 4 to the 4th equals 243 divided by 3 is 81. Take both sides to the 4th root to cancel out that power of 4, and we're going to get 7x minus 4 after these cancel equals the 4th root of 81 is plus or minus 3. So now we're going to have two separate answers, right? We're going to have a 7x minus 4 equals positive 3, and 7x minus 4 equals negative 3. All right, so if I add 4 here, that's 7x equals 7. Divide both sides by 7, we get x equals 1. Here, if I add 4, we're going to get 7x equals 1. Divide both sides by 7, we get x equals 1 over 7. So there are 2 answers for our last one. And that's it, guys. As always, let me know if you have any questions. Hope you have a great